Video part 3 ini saya akan mereview salah satu kelompok pelajaran yang ada di fungsi 3, Controlling the Operation of the Ship and Care for Person on Board at Management Level. Menurut IMO Model Course 701 Master and Chief Mate, fungsi ini memiliki 6 topik pelajaran yang harus dipelajari, dan berikut pelajaran-pelajaran tersebut. Control trim stability and stress. Monitor and control compliance with legislative requirements and measures to ensure safety of life at sea and the protection of the marine environment. Maintain safety and security of the ship's crew and passengers and the operational condition of life-saving, firefighting, and other safety systems. Develop emergency and damage control plans and handle emergency situations. Use of leadership and manager skill, and organize and manage the provision of medical care on board. Dan seperti video-video saya sebelumnya, saya tidak akan mereview semua mata pelajaran, tapi hanya akan sampling satu pelajaran saja. Dan topik materi yang akan saya gunakan sebagai sampling kali ini adalah Control, Trim, Stability, and Stress, dengan kode materi 3.1.1. Oke, langsung cari tahu gambaran tentang materi ini. Kontrol trim, stabilitas, dan ketegangan kapal. Begitulah sebutan mata pelajaran ini merujuk pada kurikulum diklat peningkatan ANT2 dengan rincian teori 35 jam dan praktek 80 jam. Namun saat saya buka IMO Model Course 701, saya rasa kurikulum ini kurang match dengan AMC 701. Kenapa? Di PK 07 BPSDM 2016 hanya memasukkan satu subtopik saja, yaitu 3.11, padahal di dalam AMC 701 topik Control, Trim, Stability, and Stress memiliki 3 subtopik. Subtopik atau kode materi 311 adalah sesuai yang disebutkan oleh kurikulum PK 07 BPSDM 2016, namun dua lainnya, yaitu subtopik nomor 312 dan 313, tidak dimasukkan. Nama-nama subtopik yang tidak dimasukkan dalam kurikulum tersebut yaitu adalah satu kode materi 312, yaitu effect on trim and stability on the in the event of damage and flooding, dan 313 yaitu knowledge of IMO recommendation concerning stability. Pertanyaan selanjutnya kemudian adalah, kenapa kedua materi tersebut tidak dicantumkan ke dalam kurikulum diklat peningkatan ANT2? Apakah oleh kurikulum PK 07 BPSDM 2016 kedua materi itu disisipkan ke dalam kurikulum diklat peningkatan ANT1? Saya cek pun di kurikulum untuk diklat peningkatan ANT1, materi itu tidak ada. Oke. Walaupun dalam kurikulum tidak tercantum materi untuk damage stability, namun di dalam buku yang kami terima dari lembaga diklat, ternyata terdapat materi yang serupa, yaitu topik stabilitas kapal bocor. Mari kita buka buku tersebut dan mencoba cari tahu apakah materi ini yang dimaksudkan oleh IMO Model Course 701. Dalam buku ini, materi yang terlihat simpel seperti ini. Membahas hanya 3 konten, yaitu bocor di tengah-tengah, permeabilitas, dan yang terakhir adalah bocor pada ujung-ujung kapal. Oke, langsung kita baca di halaman 206 sampai 212 bab 11, stabilitas kapal yang bocor. Dan seperti ini materi yang ada di buku stabilitas yang kami terima dari lembaga diklat. Halaman pertama ini adalah topik bocor di bagian-bagian tengah kapal seperti ini. Apa itu pengertiannya? Dan formula perhitungannya seperti ini. Dan langsung masuk ke contoh-contoh soal. Ini ada contoh soal pertama, langsung ada contoh soal kedua, dan masuk ke topik konten yang kedua, yaitu permeabilitas. Apa itu permeabilitas? Rumus-rumus seperti biasa, dan penjelasan singkat, dan langsung masuk ke contoh-contoh soal seperti ini. Contoh 1, contoh 2. Oke, selesai dari permeabilitas, langsung masuk ke konten ketiga, yaitu stabilitas pada kapal yang bocor pada ujung-ujung. Ini keterangan singkatnya A, B, C, D, E, F seperti itu, dan sudah hanya 6 lembar saja. Oke, setelah kita membaca materi dari stabilitas kapal bocor yang terdapat di buku diklat yang diberikan oleh lembaga diklat, mari kita coba bandingkan dengan materi apa saja yang terangkum dalam IMO Mobilcos 701 untuk kode materi 312, Effect on Trim and Stability in the Event of Damage and Flooding. Di sini kita lihat required performance-nya. Jadi di sini ada effect flooding on the transfer stability untuk kapal kargo. Di sini adalah distinguish between ships of type A and type B, bla 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 bla. Describe the extent of damage that type A ship of over 150 meter in length, bla bla bla. Explain bla bla bla. Terus perhitungan-perhitungan seperti ini disebutkan. Calculation of vessel condition after flooding, ya. Jadi ini seperti yang ada di buku diklat tadi. Jadi perhitungan kapal, perhitungan kondisi kapal setelah tergenang. Explain why the GM usually decrease where there is a large loss of intake water plane. There is intake buoyancy below the flooded space. Oke, ini adalah subtopik ketiga terakhir dari untuk kompetensi 31, yaitu knowledge of the IMO recommendation concerning the ship stability. Untuk textbook referensinya adalah T4, dan untuk bibliografinya sini banyak nih, B1 sampai B174. Oke, di sini untuk required performance-nya adalah responsibility under the international convention and codes. Alokasi waktunya adalah 2 jam. Apa saja di sini adalah state the minimum stability requirement required by Pelaut Lines 1966. State the minimum stability requirement and recommendation of the intake stability code. Explain the use of weather criterion. Demonstrates correct use of IMO crane regulation. Explains how crane healing moment information is used. Dan terakhir adalah describe the requirements for passenger ship stability after damage. Ya, selesai. Itu saja. Baik, untuk mengobati rasa penasaran, konten apa saja di dalam buku yang direkomendasikan oleh AIMO, kita buka dua buah buku yang direkomendasikan oleh AIMO model course 701. Yaitu textbook kode T4 dari Dr. Jared, Ship Stability for Master and Mates, edisi ke-6. Dan juga B3 dari Baras, Ship Stability, Note and Samples. Salah satu tujuan mempelajari damage stability yang saya ketahui adalah agar para pelaut memiliki pengetahuan tentang efek trim dan stabilitas, baik itu stabilitas merintang maupun longitudinal pada saat kapal mengalami damage, dan juga flooding of compartment, dan juga pengetahuan tentang damage control plan pada sebuah kapal. ambil contoh satu lagi sumber materi yang direkomendasikan oleh IMO model KOS 701, yaitu CPT dari Sigul. Langsung kita buka teaching aids kode V141, yaitu stability 2, damage stability, kodenya CPT 0061.
This section will explain elements of different damage stability matters of a ship and enable the user to know how the floating position changes in case of damage, know how the stability parameters change, the principle of Archimedes. When a body floats freely in the water, the mass of the body is equal to the mass of the water that the body presses away at the corresponding draft. Change in draft. When a ship has one or more damaged compartments, the draft will increase to compensate the loss of buoyancy from the damaged compartments. A new equilibrium of the floating position occurs. Healing angle. If the damage is unsymmetrical around the center line, the ship will heal. Change of trim. If the damaged compartments are in the foreship or in the aft ship, a significant trim will develop. Change in stability parameters. The sea feels the hull of the damaged ship as if the damaged compartments were non-existent. Center of gravity G and center of buoyancy B. The stability of the ship is affected by the damage. The underwater hull is completely different, and thereby the stability parameters. If the cargo and the fluids in tanks still is on board the ship after the damage, G will remain on its original location. B will change position so that B and G lie on a vertical line. Metacentric radius BM. The metacenter M will change location since the shape of the underwater hull has changed. The metacentric height GM will often decrease, but can in fact sometimes increase, depending on the width of the damage. The location of M depends on the displacement of the ship and the moment of inertia of the water plane area around the longitudinal axis through the center of flotation by the formula. Here, BM is the metacenter radius, that is, the distance between M and B. This symbol is the moment of inertia of the water plane area, and this symbol is the volume of displacement. Damage extending above original waterline. If the damaged compartments extend above waterline, they will cut a hole in the water plane area and reduce the moment of inertia. Damage extending above original waterline. Since the displacement is constant, the distance BM will be reduced. B will rise a little due to increased draft, but not so much as decrease of BM. This means that G will be closer to M after the damage, and the ship will have a smaller GM. Damage not reaching the original waterline. If the damage only affects, for example, double bottom, the water plane area will be almost unaffected. A little increase of draft gives larger water plane area and a slightly increased moment of inertia. Damage not reaching the original waterline. This means that the distance BM will increase and the increased draft will push B upwards. Consequently, GM will increase. Volume permeability coefficients. The damaged compartment in the ship cannot be completely filled with seawater because interior outfitting, machinery or cargo already occupies the compartment. The permeability of the space is expressed with a decimal or a percentage figure, that is, the maximum volume of water that can enter the compartment divided by the total volume of the compartment. This figure is used to estimate how many tons of seawater can enter the ship in case of a damage, which is used for calculating the new floating position. SOLAS gives the following figures for estimation purposes. Cargo and stores, 60% permeability. Accommodation, 95% permeability. Machinery spaces, 85% permeability. Intended for liquids, 0 or 95% permeability, whichever results in a more safer requirement. Surface permeability coefficients. When the stability of the damaged ship is calculated, the moment of inertia of the ship's waterplane area has a great influence. Not all the area of the damaged compartment is taken away, only a percentage of it. The objects that penetrate the water surface in the compartment will make small islands on the surface, and these will give the ship better stability. The surface permeability is the remaining unpenetrated waterplane area of the damaged compartment divided by the undisturbed waterplane area of the compartment. SOLAS gives the same figures for surface permeability as for volume permeability.
This section should explain the basics of damage stability calculations and enable the user to know the difference between the added weight method and the loss of buoyancy method. Use the added weight method. Understand how GZ is affected by damage. Methods. There are two main theories of how to calculate survivability of a ship after a damage. Loss of buoyancy method. Added weight method. Loss of buoyancy method. In the loss of buoyancy method, which can be regarded as the true method, the ship will have a new underwater hull form, and a new equilibrium is calculated based on this. Calculation procedure. When calculating the floating position and stability after damage with the loss of buoyancy method, the following procedure should be followed. 1. Calculate the volume of the flooded seawater, that is, the loss of buoyancy, by multiplying the displacement to the original waterline of the damaged compartment with the volume permeability of the compartment. 2. Calculate the change in draft and the new location of longitudinal center of flotation, LCF, and transversal center of flotation, TCF, for the remaining waterplane area when damaged compartments are taken away. 3. Calculate moment of inertia for the remaining waterline area based on the new center of flotation, both transverse and longitudinal. Thereafter, calculate the new BM.
4. Calculate the new location of B above keel. 5. Calculate new GM. 6. Calculate heeling angle and trim. Correction of GZ curve. True GZ for the actual damage can be calculated only if the cross curves, Km values, are calculated for the damaged hull. Application of the method. The loss of buoyancy method is not recommended when doing damage stability calculations manually. The method is more suitable for programming on computer calculations and gives a very reliable result. Added weight method. Calculation procedure. When calculating the floating position and stability after damage using the added weight method, the following procedure should be followed. 1. Estimate the mass of the flooded seawater and use this as an added weight. 2. The new draft and displacement for the ship is calculated based on this added weight. 3. Estimate the location of center of gravity of the flooded seawater and calculate the effect on the center of gravity, G, of the ship. 4. Calculate the new GM for the new draft and location of G. 5. Calculate the effect of free surface, since the added weight is a liquid, and reduce GM by the formula GGV equals I divided by the volume of displacement plus A times Y squared divided by the volume of displacement, where GGV is the virtual rise of G due to free surface effect. I is the moment of inertia of the free liquid surface in the damaged compartment. This symbol is the volume of displacement of the ship in cubic meters. A is the area of the free surface. Y is the distance between the center line of the ship and area center of the free surface. The term A times Y squared divided by the volume of displacement is a copy of Taylor's theorem that is called free communication effect of water in the damaged compartment. Notice that if the damage is symmetrical around the center line of the ship, this term will be 0, since Y is 0. This term does not exist in ordinary free surface corrections for tanks, since the tanks have no free communication with the sea. Calculate the trim list. When a new position has been calculated, it is possible to check the water level in the damaged compartment corresponds to the estimated volume of flooded seawater. If not, the procedure should be started all over again, and a new estimation of flooded water, that is, added weight, should be made. Correction of GZ curve. A new GZ curve should be calculated according to the new location of G and floating position of the ship. This curve should then be corrected for heel, cosines correction, free surface effect of the flooded water, sinus correction.
This section should explain the damage stability regulations and their meaning, and enable the user to know terms and their meaning, know and understand the requirements of the GZ curve of a damaged ship. Watertight. Watertight means capable of preventing ingress of water during static submersion under a head of water for which the surrounding structure is designed. A watertight closing appliance is also considered weathertight. Weathertight. Weathertight means that in any sea condition, water will not penetrate into the ship. Watertight bulkhead. A watertight bulkhead is a longitudinal or transversal bulkhead extending from double bottom to bulkhead deck. Margin line. The margin line is an assumed line 3 inches or 76 millimeters below the bulkhead deck of the ship. Subdivision load line. Subdivision load line is a water line used in determining the subdivision of the ship. Deepest subdivision load line is the water line which corresponds to the greatest draft permitted by the applicable subdivision requirements. Internal watertight integrity. The capability of internal structures and their closing appliances to prevent progressive flooding to volumes assumed buoyant or intact. The internal watertight integrity includes the position and type of closing appliances, alarms, indicators, remote controls, and signboards fitted to such appliances. Further, watertight closing of pipes, ducts, and tunnels in the damage penetration zone is regarded as a part of the internal watertight integrity. Progressive flooding. Ingress of water through internal openings to compartments assumed to be intact. Down flooding angle related to intact stability. The minimum heat angle where an external opening without weathertight closing appliance is submerged. Down flooding angle related to damage stability. The minimum heel angle where an external opening without watertight closing appliance is submerged. Damage zone. The zone of the ship where the stipulated damage can be assumed. The stipulated damage is defined in the applicable damage stability appliance. Residual stability. Positive range of SOLAS 90, Chapter 2, Regulation 8. Stability in final damaged condition. The stability required in the final condition after damage and after equalization, where provided, shall be determined as follows. A. Stability in final damaged condition. The positive residual righting lever curve shall have a minimum range of 15 degrees beyond the angle of equilibrium. Stability in final damaged condition. B. The area under the righting lever curve shall be at least 0.015 meter radians, measured from the angle of equilibrium to the lesser of. Click here to continue. 1. The angle at which progressive flooding occurs. Click here to continue. 2. 22 degrees, measured from the upright in the case of one compartment flooding, or 27 degrees, measured from the upright in simultaneous flooding of two more adjacent compartments.
Taking into account the greatest of the following healing moments. Click here to continue. 1. The flooding of all passengers towards one side. Click here to continue. 2. The launching of all fully loaded David-launched survival craft on one side. Click here to continue. Due to wind pressure calculated by the formula, Gz equals healing moment divided by displacement plus 0.04 in meters. Click continue. However, in no case is the righting lever to be less than 0.10 meters. Stability in intermediate stages of flooding. In intermediate stages of flooding, the maximum righting lever shall be at least 0.05 meters, and the range of positive righting levers shall be at least 7 degrees. In all cases, only one bridge and hull and only one free surface need be assumed. National rules. The National Maritime Association of countries also defines the stability of ships by mentioning of the so-called STOCO requirements. The rowboat ship shall, in addition to complying with the full requirements of SOLAS 90, survive with a defined amount of water on row deck having residual stability, according to SOLAS 90. These national rules concern row passengers. This section should explain which aids are available for decision support in the event of damage and enable the user to know and understand GM minimum curves. Know and understand floodable length curves. Know which practical precautions are to be taken. GM minimum requirement tables. The stability booklet of a modern ship contains tables of minimum GM required for the present draft and trim. This GM guarantees that the ship fulfills all the stability requirements applicable, both in intact and damaged condition, provided that the center of gravity, G, of the ship is calculated accurately. GM minimum requirement tables. For passenger ships, the maximum draft and the location of the load line mark often depends on the damage stability calculation and the deepest subdivision load line. When this draft is reached, the minimum GM requirement increases rapidly. Even though there is enough freeboard left, the draft cannot be larger if the ship is to fulfill the damage stability rules. From the floodable length curves, it is possible to see if the damage in question will cause margin line immersion. According to the damage stability rules, this is not allowed. There are often several curves in the same diagram, one for each factor of permeability. This example is from a two-compartment ship. This means that the ship shall survive damage in any pair of compartments. This can be seen in the diagram. The top of the triangles is not to penetrate the curves. We can also investigate if the ship can have three-compartment damage without margin line immersion by drawing new triangles where the base extends over three watertight compartments. Now the top should be below the curve. This is in the case for some parts in the foreship, if the permeability factor is 0.8 or below in the damaged compartments. Click here to continue. But amidship, the top will go through the curve and cause margin line immersion. the openings therein, with the means of closure and position of controls thereof, arrangements for the correction of any list due to flooding, cross-flooding and down-flooding arrangements. Generally, a passenger ship cannot fulfill the stability rules if the damage is unsymmetrical around the center line of the ship.
Demikian video review salah satu materi pembelajaran di kelas Pelaut ANT2 untuk fungsi 3. Rekan-rekan bisa menilai sendiri apakah materi pelajaran control, trim, stability, and stress yang kami terima sudah sesuai standar atau belum. Terima kasih sudah menonton video ini. I'm Del tadi. See you on next video.